Hello, everybody. I hope you're doing well. So we're going to continue today to learn how to make Lewis structures. As you recall, Lewis structures is a model, a two-dimensional model of what molecules look like. So we're going to try to finish page 8, 9, and 10 and get started on page 11 and 12. So be sure to have a hard copy of the unit packet in front of you so you can take notes as we go through this. So let's get started. So here's where we left off. I am actually going to get rid of my face here so that there's more room on the page. Okay, so we have SO3, that's 1 sulfur and 3 oxygens. Now, what is this molecule? Let's go to our table of ions, and you can see it down here, sulfite. SO3, it has a -2 charge. Okay, the way we do this, why don't I put the name right there, sulfite. So the way we do this is we count how many valence electrons each atom in the molecule brings into the molecule. So we have sulfur and we have oxygen. So go to the periodic table, and here you can see that sulfur and oxygen are both in column 16. So what that means is that each of them, each sulfur and each oxygen brings in 6 valence electrons. The sulfur brings in 6, the oxygen brings in 6, but there's 3 oxygens, so I have to multiply that by 3. So 6 times 3 is 18, plus 6 is 24. Now, notice this has a -2 charge. Well, how can it have a -2 charge? Well, it must have 2 extra electrons, 2 extra negative charges, so that you have to add 2 because of those 2 electrons. The total equals 26. So you have 26 electrons, valence electrons available to make sure that every atom in this molecule has 8 electrons. And that's the magic number, that's the octet rule, that makes sure that they are stable. So the next step is to put the first atom in the center. So I'm going to put sulfur in the center since it's the first atom in the formula. And that's pretty much for most molecules. There are some exceptions, and I will point them out. Now we're going to guess the shape using single bonds. So I'll use a single bond to put an oxygen up here. I'll use another one to put an oxygen over here, and another one to put an oxygen over here. Now notice that I use 3 single bonds, and if you look over here, you notice that a dash indicating a single bond is worth 2 electrons. So I just used up 6 electrons. So I'm going to subtract it from my total, and I'll get 20 left. Okay, so now I have to stabilize these atoms, making sure they have, every one of them has 8. We always start with the outer atoms first. By the way, these outer atoms are called ligands. Ligand. Like everything in chemistry, everything has a name. So these atoms, these oxygens, these ligands, each of them needs 6 more because they have the single bond, they're sharing with the sulfur, that's 2, so I'm going to put 6 on this oxygen. 3, 4, 5, 6. Put 6 here, 1, 2, 3, 4, 5, 6. And 6 here, 1, 2, 3, 4, 5, 6. So now each oxygen in this molecule is stable, and each one used 6. There's 3 of them, so I used up 18 total. And I have 2 left over. And notice the sulfur already has 6 from the 3 single bonds, and it needs 2 more. 1, 2. Okay, so you used up all your electrons, and you really don't need any more because every atom in this molecule has 8 electrons. Now there's one more thing I want you to do, and that is to put big, huge brackets around it, just to let people know that it has a -2 charge. Okay, what about the next one? Carbon with 3 oxygens. What is this? So here it is up here. This one is called carbonate. Right, carbonate. Okay. Now notice, when did I get, I need to make some room. I'll erase all this. Okay. Okay, so we have carbon and we have oxygen. How many valence electrons does carbon have? I forgot. So I have to go to the periodic table. Here it is right here, carbon. It has 14 as a column number. 14 minus 10 is 4. So carbon has 4. Oxygen, as you recall, has 6, but we have to multiply by 3 because there's 3 of them in there. 6 times 3 is 18, plus 4 is 22 valence electrons. Okay, so I'm going to put the carbon in the center as our procedure requires, and then I'm going to attach the oxygens with single bonds. So I'm going to guess that it looks something like this. Okay, I used up, oh, by the way, I forgot, we have to add 2 valence electrons because there's a negative 2 charge. So we have a total of 24. 24, and I used up 6. 24 minus 6 is 18. Okay, so I'm going to stabilize the oxygens. Each of them needs 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So notice I used up all my valence electrons, but we have a problem because this carbon, it only has 6. It has 6, 2 from each single bond. It has 6, it wants 8. So where is it going to get those extra 2 electrons? Well, what I'm going to do is I'm going to pick an electron pair and I'm going to make a double bond. Okay, so I got rid of those 2 electrons and I'm going to make a double bond. There we go. Notice that this oxygen that I got these electron pair, it still has 8. It's got the double bond, that is worth 2 because each dash is worth 4 because each dash is 2. 3, 4, 5, 6, 7, 8. The carbon now has 8. The double bond, that's 4. And then the 2 singles, that's 4 more, that's 8. So the last thing I want to do is I want to put brackets around it and put a 2 minus. Okay, I'm going to let you try to do carbon. This is carbon monoxide. Remember, carbon monoxide. Very toxic gas. I'll let you guys try to do that. Okay, here's water. Water, we have an H and an O. H has 1 valence electron, you will recall. Oxygen is in column 16, it has 6. H, there's 2 H's, so I have to multiply by 2. The total is 8. Now this is an exception when we design these molecules. Hydrogen never goes in the center because it can only have 1 bond. So hydrogen, in this case, you would have to put the oxygen in the center. So I'm going to predict the shape. I'll put a hydrogen over there, and I'll put a hydrogen over there. In that process, we have 2 single bonds, so you used up 4 electrons. You have 4 left. Now hydrogen, it only needs 2 electrons and it has a full shell. So this oxygen, however, it needs 4 more. And guess what? You have 4. So I'm going to put 2 up there and 2 down there. And there it is. Water or you could call this dihydrogen oxide. Okay, I'm going to do one more on this page. Why don't we do the SO2, SO2, sulfur dioxide. Okay, so we have S and we have O. S is 6 valence electrons, O is 6, but there's 2 of them, so you have to multiply by 2. 12 plus 6 is 18. Okay, I'm going to put the sulfur in the middle. I'll put an O over here, and how about if I put an O over there? So 18 minus 4 equals 14. I've got 14 left. 1, 2, 3, 4, 5, 6. Now that oxygen is stable. 7, 8, 9, 10, 11, 12. Now that oxygen is stable. So I've got, how many did I use? 12. I've got 2 left. I'll put them up here. Now I have no electrons left. None left. So notice the oxygens are stable, but this sulfur is not stable yet. It only has 6 valence electrons, 2 from that single bond, 2 from that single bond, the second single bond, and then 2 from the lone pair. We call this the top. Whenever you have an electrons pair that is not bonding, we call it a lone pair. They're lonely. Okay, so how does this sulfur get 2 more electrons? Well, what we're going to do, and just pick 2 electrons. It doesn't matter which ones you pick. How about if I pick these? I'm going to pick these, and I'm going to form a double bond. Okay, so I have to get rid of those. Okay, now notice that every atom in this molecule has 8 valence electrons. The center sulfur has 2 from that single bond, and then it has a double bond, that's 4. And then it has the lone pair, that's 2 more, equals 8. Okay, I think this video's gone on long enough. I'll tell you what, why don't you guys try to do the last 2 on your own? And again, you can, try them, make an attempt, see if you can do them, make your proposed shape, and then you can go online and check your work. So I hope you are having a good time. Oh, by the way, please check the Google Classroom. I'm going to go post a couple of videos on that talks about how we use science to develop a vaccine. And take a look at that. You're going to learn a lot about the coronavirus and what we're doing to meet this crisis. So take care. Talk to you later. Bye-bye.